Welcome. This is 6.8 task. It's called signing and co-signing it, and there's a person with a document they're about to sign, and it's a terrible pun. But anyway, this is about something called the unit circle, and the unit circle is a circle with a radius equal to 1, and that simplifies things and makes it useful for us to understand some of the coordinates, x and y coordinates on the circle that you can find in terms of the cosine and sine functions. So the first thing is going back, the total circumference is always 2 pi times r, so that would be all the way around the circle. Therefore, to find the arc length, it's part of that circumference, right? So for example, this arc, this very first arc here is 1/16 of the distance around the circle because it's split into 4 pieces and there's 4 quadrants, so it's 1/16. So 1/16 times 2 pi r, where r is equal to 1, would be pi over 8. So on the unit circle, the length right here, the arc length is pi over 8. Each of these arc lengths are going to be equal. So you've got pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. That actually matches the angle measure in radians of pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. So the other thing that we're trying to do is we're trying to find a way to see what are the positions for each of these stakes. And we're going to use the cosine function and the sine function to find the position. So for example, let's look at the first one. This right here is our triangle that we've been working with, okay? And so to find the x position, the horizontal distance here, we're going to use r times the cosine of theta. In this case, r is 1, and that really simplifies things as we calculate. So for example, for an angle measure of pi over 8 radians, the x value is the cosine, 1 times the cosine of pi over 8, which is about 0.92. That would be this distance right here, 0.92. And that would be from here to here. That is the x value, that's 0.92. To find the y value, which is the height of this triangle right here, and that one you're going to use your sine function. The radius is 1, so it's going to be 1 times the sine of pi over 8, which turns out to be approximately 0.38. So my coordinate point right here is at approximately 0.92, 0.38. That is my pi over 8. Now, let's look at another one here. I'm going to just remove this so we're not distracted by that. There we go. What about pi over 4 radians? And so this would be this particular triangle here. Not only is it a right triangle, but it is also a isosceles right triangle because we can see that this angle and this angle are going to be congruent. Those are 45-degree angles. So we have an isosceles right triangle. And if you remember, we had some ratios we used before, like 1 square root of 2, or another one was 1 square root of 2 over 2 and square root of 2 over 2, right? And this is the one that's going to be useful for us because the radius is equal to 1. Okay, so the same process here. We have a 45-degree angle here at pi over 4 radians, which is equivalent to 45 degrees. That's why we know it's isosceles right triangle. And so therefore, to find the x value, we already know that it is exactly the square root of 2 over 2 and square root of 2 over 2 for those two sides because it's isosceles. That's approximately 0.71. If you do sine and cosine functions and you get a 0.71, you're probably looking at the square root of 2 over 2 as your value. So that is our pi over 4. Now, there's some others that we don't have to redo these calculations because of the symmetry on these triangles. So let me show you what I mean by that. We got 3 pi over 8. If I set this triangle up and I compare it to this triangle, notice that these two triangles, this yellow triangle right here at pi over 8, and this other triangle here at 3 pi over 8, notice that those right triangles are the same. They're congruent. It's a matter of rotation and translation that and reflection actually that we can use to show that those are congruent. So because these are the same triangle, what you notice, what swaps is the x value of this triangle, because this side right here becomes the y value of this triangle. Same thing here, the y value of this triangle that we calculated becomes the x value, because these are two sides of the same triangle. And so therefore, without doing the calculations, we could swap the x and y values, 0.38 and 0.92, and that represents the position. Now the last one is if you're at pi over 2 radians, or 1/4 of the way around a circle. This is the high point of the circle, and because the radius is equal to 1, and looking at our xy axis over here, you can see that x is going to be right at 0 and y is going to be equal to 1.